Okay, this is the digestive system. Bismillahirrahmanirrahim. For the anatomy and physiology block, pre-med 211 for the spring semester 2020. This is the learning outcomes of the digestive system. By the end of the lecture, the student should be able to list the components of the digestive system, including accessory digestive organs. So hopefully we will discuss in this part 1 the digestive system itself, and what is the accessory part we will discuss in the part 2. Then we have to describe the anatomy of the oral cavity here in part 1 with the tongue and salivary glands and the wall of the digestive system. Then we will go one by one different parts of the digestive system like esophagus, stomach, small intestine, large intestine, and finally we will go to the blood supply of the whole GIT, means gastrointestinal tract. Okay, this is a slide mentioning the organs of the digestive system, and we can go one by one with slight introduction. The salivary glands that secretes for the lubricating the bolus, right, and that secretion contains the enzymes that break down the carbohydrate. So start of digestion, it starts from the mouth, then the pharynx, the muscular uh, tube that is used for propulsion of the material into the esophagus. Propulsion, pushing the bolus into the esophagus. Esophagus is the tube, and through the tube the bolus passes through the stomach, and stomach is the main uh, uh, part of the digestive system where the breakdown of the material takes place through the acid enzyme mechanical processes, through the muscular contraction, mechanical contraction, it's also called as small intestine, enzymatic digestion, absorption of water and organic material, vitamins and ions. The large intestine, dehydration and compaction. Compaction means to make it more compact, solidify, right? So they absorb all the water. So these are more physiological aspects. So all the indigested fluid material, they form the fecal material. Then from here, oral cavity, teeth, tongue, what is the function of these? These are mechanical processing, moisturizing, mixing, salivary secretions. So this teeth and oral cavity, tongue, they all act like a stomach, because stomach, they break down the material through the acids, and here they break down the material through the teeth. So they are mechanically more in action. Then liver has got secretion. The secretion of the liver is called as the bile, and that is important for the lipid digestion, storage and nutrients of the material through vital organs. Okay, gallbladder is storage and concentration of bile that is secreted by the liver, right? Always remember the secretion of the liver is called the bile. Pancreas, its secretion is called pancreatic juice. So exocrines and endocrine, both the types of cells are present in the pancreas, so that's why it is called a mixed gland. So exocrine secretion that buffer the acidic secretion in the duodenum, and the digestive enzymes, they also use for digestion. Endocrine cells secrete hormones also. So hormones like insulin and glucagon, somatostatin. Now in the next slide, there are some general concepts for the digestive system. Abdomen is a cylindrical chamber extending from the inferior aspect of the thorax to superior margin of the pelvis. Abdomen and pelvic cavities are continuous. There is no wall, there is no septum like diaphragm between the thorax and the abdomen. Abdominopelvic space is called as the peritoneal cavity. So it is a whole continuous space, abdomen and the pelvis. Pelvis is the space that is within the hip bone, right? Within the pelvic bone, right? So that is the pelvic structures and pelvic cavity, and the abdomen is above the pelvis. Then abdominal viscera are also suspended within the peritoneum. So all the things that are there in the abdomen and peritoneum, they are by the peritoneal membrane. This layer, oral cavity, this slide, oral cavity, the buccal cavity. Buccal, in medical terminology, you have studied this. Buccal means cheek. So cavity of the mouth, the cheek cavity mouth, extends from the lip to the pharynx. So lip is this one. This is the upper lip, the cut section, and there are lower lip, again the cut section. So this is the anterior most end, and the posterior end of this oral cavity is this opening that opens into the pharynx, and that part of the pharynx called the oropharynx, because it is in relation to the oral cavity. It is divided into two parts. So vestibular part, and the second part is the mouth cavity proper. Vestibule is the space between the lip and the cheek. Can you see this small space uh, between the teeth and the lip? So the space that is between the lip here in the lower lip and the teeth, this space is called as the vestibule. And this space is not only here along with the anterior part, this space between teeth and the upper lip, but it is circulating all along the teeth and the cheek. So on the lateral side, it is the cheek muscle. So between the cheek muscle and the teeth, the space that is like here, very small slit like space, that is space on both upper and lower jaw, that is called the vestibule. It communicates with the mouth proper behind the third molar tooth. Okay, mouth proper is what? Cavity proper, it extends from teeth in front to the root of the tongue behind. So what is remaining where the tongue is located? So from one teeth to the another teeth, means the right sided row of the teeth and the left sided row of the teeth, the whole space between the two sided teeth, that whole space that also contains the tongue and the cavity, that is called as the mouth cavity proper, right? And here both these cavity, vestibular space and this mouth cavity proper, they connect, they communicate with the behind the third molar tooth. Now there is the teeth row, the molars are at the end, the last third molar in the adult, behind that one there's a small space, right? So this space, this is the area that communicates between the teeth and the cheek and the teeth and the teeth, the oral cavity proper, right row of the teeth and the left side of the teeth. So behind the third molar, there is a space, there is a communication between the vestibular space and the oral cavity proper. Then we have got the boundaries of the oral cavity: superior, roof, hard palate, anterior, and soft palate. Hard palate is a cut section. This is the roof of the oral cavity, and this is also called the floor of the nasal cavity, because what is above this palate, this is the nasal cavity. So this forms the floor of the nasal cavity, and this forms the roof of the oral cavity. Now this, if you in the cut section, you can see that this is the bony part, maxilla, right? And if you go backward, this is the muscular part. The muscular part is called as the soft palate, and the bony part is called as the hard palate. So this forms the roof. Then come to the anterior and lateral wall of the oral cavity. Cheek, this muscle, cheek muscle, the buccinator muscle, they usually form the lateral wall of the oral cavity. And anteriorly, we have got the lips, upper lip and lower lip. And what is the name of this muscle that form the upper and lower lip that surround the oral cavity, the opening of the mouth? That muscle is the orbicularis oris. Then come to the posterior is the uvula, palatine tonsils, and the root of the tongue. Now these are three structures. This is the oral cavity, the posterior part, where there is an opening that opens into the pharynx, the oral pharynx. Name this structure. This is the soft palate, this gland, this is the palatine tonsil, the lymphoid tissue, and this structure is what? This is the tongue, right? This hole is the tongue. Actually, tongue is a muscular part, and this is covered by the mucous membrane, and this is the posterior part. So the posterior of the oral cavity proper is bounded by the. Now this soft palate, if you see it from the front, you'll find the center hanging muscle that is called the uvula. So this central part that is hanging in the center, when you open up your mouth and look into the mirror, posteriorly you will find a hanging central muscle that is called the uvula. So that muscle is also the part of the soft palate. Then this tonsil, and this is the root of the tongue, right? So tongue starts from here anterior to the epiglottis. So this is the root of the tongue. That is, the identification is that these roots, they contain big papilla, so they are rough, and the anterior one is smooth. So this is the root of the papilla that also form the posterior. Now inferior tongue skeletal muscle. Now that was the roof, that was the lateral wall, anterior, posterior. Now come to the roof. This tongue is one of the content of the oral cavity. Regarding the floor, these are the muscles here. There are two muscles. This is a mylohyoid muscle and this is a genohyoid muscle. So these are the tongue and skeletal muscle. So this tongue from here, this is the genoglossus muscle. This is the genohyoid muscle. This is the hyoid bone. This is the mandible. The inner surface of the mandible has got the genial tubercles, right? So these are the two the attachment for the genohyoid, right? So hyoid and the genial tubercle on the inner surface of the mandible. And lower down, this is another muscle. This is called the mylohyoid, right? So they form the tongue and these muscles, genohyoid and mylohyoid, they form the floor or the inferior wall of the oral cavity. Okay, next slide. We have the tongue. Tongue, this is the superior view of the tongue, right? As we have discussed, this is the superior view of the tongue, right? This is the epiglottis at the back, and this is the root of the tongue, rough part that is showing so many papillae, right? So this papilla mention the root, and the anterior 2/3 is the smooth part. Okay, how we divide the tongue? Can you see this victory, like we inverted this line? This line is called sulcus. Sulcus means depression, terminalis at the end. So at the end here of the tongue, we have got a depression, and this is a depression called as sulcus terminalis. So anterior to this sulcus terminalis, this comprises the 2/3 of the tongue. So this is the anterior part. So anterior 2/3 of the tongue, and behind this one is 1/3, the root of the tongue. So this is called the posterior 1/3. Anterior 2/3, posterior 1/3, divided by sulcus terminalis. Right. The tongue is a mass of striated muscle covered by mucous membrane. As in the cut section, we have seen the tongue comprising of so many muscles, right? And here, regarding the muscles, you can see that there are 1, 2, 3, 4. All the muscles that are named with a glossus in the end, like genioglossus, uh, hyoglossus, styloglossus. So these glosses, these are the main muscles, right? There is another muscle called as genohyoid. So there is the genohyoid, there is the genoglossus, right? Look at the lining, genoglossus, genohyoid. This one, styloid process is here. So styloglossus, right? This is the tongue. So styloglossus, and then this green color muscle, this is the hyoid bone, long horn. So this green color is a broad one. So this is hyoglossus. So hyoglossus, styloglossus, genoglossus, and this is genohyoid. So they are supposed to be the muscles of the tongue. These are called as the extrinsic muscles of the tongue. There are some intrinsic muscles that are only inside. So vertical, horizontal, and transverse, these are the three intrinsic muscles that are present only inside they are arising and finishing inside the tongue. They are not coming from outside. Since they are coming from outside of the tongue, so they are called as the extrinsic muscles of the tongue. Now, the tongue is a mass of striated muscles covered by mucous membrane. Okay, this is the mucous membrane with papilla. Papilla, they usually contain the taste buds inside, right? Now come to the mucous membrane. Mucous membrane, upper surface of the tongue, can be divided into anterior 2/3 or oral part, and the posterior 1/3 or pharyngeal part by a V-shaped sulcus, the sulcus tunnel. Now this is more towards the pharynx. So this one, the posterior 1/3, the posterior 1/3 or pharyngeal part. So it is facing toward the pharynx, so it is called pharyngeal part. And this anterior 2/3, it is facing the oral cavity, so anterior 2/3 or the oral part. So oral part or anterior 2/3. pharyngeal part or posterior 1/3 of the tongue. Now come to the sensory nerve supply. The nerve supply to the mucous membrane. Now here we have divided anterior 2/3 and posterior 1/3. Which part? Not the muscle. We have divided the mucous membrane because this is the highest membrane that is covering the surface of the tongue, right? So below this membrane, this mucous membrane, we have got the muscles. Now we are talking about the mucous membrane, not the muscles. Muscles of the oral cavity, they are innervated by which cranial nerve? The 12th cranial nerve, that is called the hypoglossal nerve, right? Except one. So here again, now we are dividing this mucous membrane that is covering the muscles of the tongue, right? This mucous membrane is sensory. So here we are discussing all about the sensory innervation, right? So sensory, all the sensation from the anterior 2/3 of the oral part, this one. Now sensation, general sensation and special sensation. When we call about the general sensation include the pain, touch, temperature, pressure, all that is, right? So those general sensations, they are carried through the which branch of the nerve? Lingual nerve. And this lingual nerve is a branch of the mandibular division of the trigeminal nerve, right? So trigeminal nerve, it's called tri because it has got three main division of thalamic, maxillary and mandibular. So the mandibular division of the trigeminal nerve give a branch called as the lingual nerve, and that lingual nerve carries the general sensation from the anterior 2/3, that is the oral part of the tongue, right? Now come to the posterior 1/3. Oh, sorry. This so general sensation is carried through the lingual nerve. Now come to the anterior 2/3 again, but special sensation. Special sensation for the tongue is what? Taste. So taste is a special sense. It is sensed by the taste buds. So taste buds, they are usually present in the depression of the papilla. So these are called papilla, right? They are big one. They are again bigger, valvate papilla, and there are some valvate valvate papilla. It's very small here. Can you see this dot 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 dot? So they are very numerous. So those papilla, they are very small comparing to this big one. Big ones are very visible. So these papilla, in their depression, they contain the taste buds. So now special sensation from the anterior 2/3 of the oral part of the tongue, it is carried through the chorda tympani. Okay, chorda tympani is a branch of the facial nerve. So facial nerve that supplies the muscles of the face, right? Facial expression muscles. Zygomatics major, minor, orbicularis oris, orbicularis oculi, right? Nasalis. So the same facial nerve, it give a branch, but it takes the so facial nerve itself is a mixed nerve, motor and sensory. So motor part supplies the muscles of the face, and the sensory part is carrying spatial sensation through which branch? Chorda tympani. This is the name of the nerve. Now come to the posterior part. Posterior part again, general sensation and spatial sensation. Both means in this posterior 1/3, the taste buds that will give the spatial sensation. So both are carried, both the general and spatial, they are carried by the glossopharyngeal nerve, that is the 9th cranial nerve. Motor nerve supply to the muscles of the tongue. Now this is the mucous membrane. When you remove this mucous membrane, inferiorly you will find these muscles, right? So these muscles, now they are, when you innervate the muscles, they are called the motor nerves, right? So motor nerve supply the muscles of the tongue and is from the hypoglossal. So which one is the hypoglossal? Now come to the next slide. In the next slide, we have uh, we will discuss different glands, and in the glands we have got salivary glands, and in the salivary glands, so the saliva, the secretion that lubricates and softens the bolus what you eat and is then chewed easily. So those salivary secretory glands, they are exocrine glands, and every exocrine glands, they have got a duct, right? So when we say the exocrine gland, so all are usually the exocrine glands, parotid, submandibular, sublingual, right? So they have all of them, they have got the ducts. Now, are the salivary glands open and secrete into the oral cavity? Minor salivary glands are located throughout the submucosa of the oral. They are minor, and these glands, they are called the major. Major means larger, big one. These are the glands, and they are minor salivary glands. They are just below the mucous membrane of the oral cavity inside. Now come to one by one. The major one, the largest salivary glands, parotid gland. Largest salivary gland, and on the lateral side of the face. So this is the face, this is the lateral side. It is opened up just to show you this. The skin is removed, and below the skin and below the ear, in front of the ear, right? Antero-inferior, you will find this pyramidal shaped triangular parotid gland. And you can see from the parotid gland, can you see this green color duct? This green color duct, this is called as the parotid duct, right? And this duct opens to the oral cavity. Where in the oral cavity? In the vestibular area, in the cheek. And you can see this is showing the opening of the parotid duct. So this parotid duct, it pierces the buccinator muscle, because the buccinator muscle, this is the cheek muscle. So this duct actually runs on the masseter. Which muscle is this? This is the masseter. And then it pierces this buccinator and opens over here. Now, parotid gland, largest salivary glands, lateral side, it's composed mostly of serous acini. Serous acini means water and electrolyte and enzymes, right? They are not for the lipid secreting function. Its duct empties in the vestibule of the mouth, opposite to the second upper molar tooth. Not the lower molar tooth, not the first, not the third. Second, upper second molar tooth. Now, come to this. Salivary glands. So we have discussed the parotid gland. Now come to the other two glands. Other two glands are submandibular gland. Submandibular means below the mandible. So where is the mandible? Mandible is this cut part, right? So this cut part below this mandible, this is continuous here. This is the parotid gland, right? We have discussed, and we have discussed the parotid duct. Pierces the buccinator. It runs on the masseter. It does not penetrate the masseter. It runs on the masseter, but it penetrate, it puncture the buccinator, right, and opens into upper to second molar. Now, second gland is submandibular. Submandibular gland is this one. Below the mandible is here. It's appearing as small here, right? But it is, it's got two parts. Submandibular glands. And where is the duct? Here is the duct. And this duct is passing medial to this gland. And can you see this duct continuous here? So this is a submandibular duct, and this is continuous here. So this is the duct, one single duct, that is submandibular duct, and this, it opens just below the tongue. So below the tongue you will find here the sublingual fold, indicates the position of the sublingual gland, and at the end you will find the first opening in this row. You will find the opening of the submandibular duct. Now, submandibular duct lies on the medial surface of the mandible, right, definitely, and it is divided into superficial and deep parts by the mylohyoid muscle. So this is the deep part, and the muscle, the mylohyoid, this one that is removed from here to show the deeper part. It consists of a mixture of serous and mucous acini. Serous, water electrolyte enzyme, mucus, lipids, right? It secretes both the types of secretions. Its duct drain into the floor of the mouth near the lingual frenulum, posterior to the lower molars. Near the lingual frenulum. What is frenulum? This is the frenulum, the structure that attach the lower surface of the tongue with the floor of the oral cavity, right? So this is called the frenulum. When you lift the tongue in the mirror, you can see lifting your tongue up. Posterior to the lower mandibles. Okay. Lower mandible here, you will find it. Then we have got the sublingual. Sublingual, as the name is indicating, it is below the tongue. Smallest salivary gland. It has both serous and mucus, same like submandibular, but the parotid only contains the serous. Acini are the lowest part, the glandular part of the gland. There is a ductal part and the glandular, with the later predominating It is drained later. Predominating means serous and mucus. So some later the dominant part of sublingual gland is mucus, means in lubrication, fatty droplets. It is drained by 10 small ducts which open to the floor of the mouth near the lingual frenulum. Now find the 10. So 8 to 10. This is the gland, this is the sublingual gland, and you can see these small, many small ducts. 1, 2, 3, 4, 5, 6, 7, 8. So 8 to 10 usually it's written. So here 8 small ducts. So these 8 small ducts, they individually they open on the side of the frenulum. So this is the side where the first opening is the opening of the sublingual gland, submandibular gland, and the remaining opening here, there are 8 openings, right? They will show you. So these are the openings of these 8 ductal sublingual glands. Now come to this part. This is the wall of the gastrointestinal tract. Wall of the gastrointestinal tract composed of 4 layers: mucosa, submucosa, muscularis mucosa, and serosa. Serosa is basically the peritoneal layer, the outer covering, the outer peritoneum. So now this is a slide that is mentioning the different layers of the wall of the gastrointestinal tract, GIT. So 1, 2, 3, 4 layers. The fourth layer, the serosa, we start from the outside. Can you see this covering? So this covering here, it is written serosa with connective tissue and the epithelium. This serosa is actually the peritoneum, right? So any structure that is all enveloped, circled by this peritoneum, that is called intraperitoneal, right? And in the abdomen, organs they are surrounded by, and then the two layers of the peritoneum, they unite together, and that become the passage for the entry of the artery, veins, nerves, lymphatics into that organ. So this organ, just like the hilum, the concept of hilum is that the area, the surface area through which all the vessels and structures they penetrate the organ and come out from that area. Same is true here. When any peritoneum that is covering the organ, that area where the two layers of the peritoneum after encircling they join together, that double layer of peritoneum, that is called as the mesentery. And what is the purpose of this? This also helps in the passage of the arteries, nerves, veins, all into the to the organ, right? So this is the serosa. So serosa is actually, now what epithelium is this? Peritoneum is a mesothelium, and all the mesothelium, they are simple squamous epithelium, right? So which type of epithelium? Simple squamous. Now after outside, come to the easy layers, the mucosa. Now mucosa, uh, this is the innermost layer, right? And in the innermost layer, you will find that this innermost layer is further divided into epithelium, lamina propria, and muscularis mucosa. So muscularis is this. Muscularis is third layer. Muscularis means any muscle layer, right? So this muscle layer is the muscle layer of the mucosa. That's why it is called muscularis of the mucosa. And this is only muscularis, means it is something only the muscular layer, the proper muscular layer. And when it's a muscle of the mucosa, it is called muscularis mucosa. Now where are all these? So first of all, you will find this is the mucosa here, and mucosa has got the epithelium. So this innermost, this is the lumen of the tube, whether it's a tube of esophagus or the cavity of the stomach or cavity of the small intestine or cavity of the large intestine. So this is the innermost layer, the epithelium. Which type of epithelium is this in the GIT? Simple columnar epithelium, right? Then below the epithelium, can you see? Okay, can you see these small glands from the surface epithelium? These are the glands. So these glands are called the glands of the mucosa. They are very small one, and they are also present in the oral cavity or below the mucous membrane. So this is the gland of the mucosa. Now, after this epithelium, simple cuboidal epithelium and the glands, you'll find lamina propria, this white color. This white area is called lamina propria. So lamina propria is a connective tissue layer, right? It's a loose connective tissue layer, right? And in the loose connective tissue layer, you may find mucosa associated lymphoid tissue malt. So malt, its location is in the lamina propria. Then after this lamina propria, loose connective tissue, because this loose connective tissue also provide the arteries, small arteries and veins, right? Because you know in the epithelium is avascular. There is no blood vessel here. So below the epithelium, there must be some blood vessel so that they can give nutrition to the epithelial cells, that they don't die and they also divide and grow. So this lamina propria is loose, containing blood vessels, small blood vessels. Okay, arteries, vein, nerves. Muscularis mucosa, this is the outermost muscle. So this is the third part of the mucosa. You can see this muscle. So this is the muscle, same muscle, just like here, right? But these are thick, they are broad muscular band, and these are small stripe of muscle, a single small stripe. They are very thin, but this is a muscle, right? Which type of muscle? In the organs you find the smooth muscles, right? So these three layers, they in combined form, this is called as mucosa. So first layer, epithelium, lamina propria, loose connective tissue containing blood vessels, arteries, nerve, veins, and some glands, plus mold, lymphoid tissues, right? Then after mucosa, we have got the submucosa. Submucosa means below the mucosa. So below these three layers. So after these three layers, you will find another layer, this white color area. This is below the mucosa, right? So whenever we say the mucosa of the digestive system, we mean these three layers, right? And below these three layers is the submucosa. Now in the submucosa you will also find this gland. So glands of the submucosa. So in the submucosa, in different parts of the digestive system, there are different glands, right? So these are the glands. You can see this is the duct that is opening into the lumen, but the duct is only piercing the mucosa, all the three layers of the mucosa, but the gland itself is present in the submucosa. This is very, very important to know, that the gland itself, they are usually the popular glands, they are present in the submucosa, but the duct, it moves up and penetrate the three layers of the mucosa and open into the lumen. Now submucosa also, you can see this artery, veins, nerves. So this is again, so these arteries, vein, nerves, they are also present in the submucosa. Then muscularis, the muscle. Here is, this layer is only composed of muscles, right? And there are two types of muscles. Can you see the difference between the two layers of the muscles? This muscle is circular muscle, right? The inner one. So inner one is almost always a circular muscle, right? And the outer one is almost always a longitudinal one. This is long, right? Their fiber direction is long, and here the fiber direction is circular, right? So inner circular, outer longitudinal muscle. So this is a muscularis externa. Sometimes this muscle, to differentiate histologically, this layer is called as muscularis externa, and this muscle layer that is thin, the part of the mucosa, is called muscularis interna, right? So these are the layers of the wall of the digestive system. In the next slide, wall of the digestive system, four layers, mucosa consisting of so again, mucosa consisting of three layers: inner epithelial lining that vary with location. From the esophagus to the anus, we have got the simple columnar epithelium, right? Lamina propria is a layer of areolar connective tissue, means loose connective tissue, or with it can be compressed easily under the epithelium, below the epithelium. Muscularis mucosa is a thin layer of smooth muscle next to the lamina propria, below the lamina propria. Then after mucosa, we have got the submucosa. Submucosa layer is a dense, irregular connective tissue. Now, which type of connective tissue is this submucosa? Okay, it is loose connective tissue, but it is a connective tissue, but it is dense, irregular connective tissue. So what is the another example of dense irregular connective tissue? The dermis of the skin, right? Dense irregular connective tissue. And for the regular, tendon. Okay, that's this dense irregular connective tissue that surrounds the mucosa. So this is the mucosa three layer. It surround. There is a submucosa, dense irregular connective tissue that contains the blood vessels, nerves, Meissner's plexus. Meissner was the scientist who discovered this thing. So the nervous plexus, if you see in this submucosa, this yellow colored nerve branches, there is a plexus, the nervous plexus. So this mucosa, since it is present inside the submucosal layer, so this plexus is called as submucosal plexus or plexus of Meissner's. So Meissner's plexus, scientist name, but according to location, we can say it as submucosal plexus, right? Because there is another plexus. Then what else in the submucosal layer? Lymphatic vessels, glands. Then coming to the muscular external. Muscular is external. Look here, muscularis mucosa, that is also called as muscularis interna. In differentiating that this muscularis is not the muscularis mucosa, they named it as muscularis externa. So in so many books, this layer is called muscularis externa. So this muscularis layer or muscularis external layer, it has got inner circular, outer longitudinal muscle layer. Inner circular squeezes the duct. Consequently, when circular muscle contract, it squeezes, it compresses the content hardly, and the outer longitudinal muscle shortens the gut for movement of the material. So peristaltic movement, both of them is a combined effect. The longitudinal one is actually for pushing and circular for crushing. Is present between these muscles. Such a myenteric plexus, nerve plexus, just like Meissner's nerve plexus was present in which layer? Submucosa. So in the muscularis, myenteric nervous plexus. Myenteric, myo means muscles, enter means intestine. So muscle of the intestine, if you remove these two muscles, can you see this nervous plexus? This is the nerve, right? So this nerve and inside nerve, above the longitudinal muscle and sandwich between the circular and the longitudinal muscle. This nervous plexus, both of them, they are called as the myenteric plexus by the name of Orbeck. Orbeck, plexus of Orbeck, Orbeck plexus, right? So myenteric plexus or Orbeck plexus. In the exam, they can ask you in both the ways. Serosa, visceral peritoneum. Peritoneum, I told you, just like pleura, pericardium, it is double layered. The inner layer that covers the organ, it's called visceral layer, and the outer that covers the wall, peritoneal, parietal layer. So this serosa is actually the visceral peritoneum that covers the muscularis externa along most of the digestive system or tract. Come to the next slide. Next slide is showing you the esophagus, right? So esophagus, we have another thing. So in the esophagus, we have again the esophageal is a muscular tube, but it is composed of muscles, right? Connects pharynx to the stomach. Major portion of the esophagus lies in neck and thorax. Definitely, esophagus, it is connected from the pharyngeal area, and it passes through the thorax and enter into the abdomen. So major portion of the esophagus lies in the neck and the thorax. A very small portion enters into the abdomen and immediately connect with the stomach. The muscularis, superior third of the stomach of the esophagus is skeletal. Lower two-third is smooth muscle. Now here if you see, this is the oral cavity, pharynx, right? And this very long esophagus, and this is the stomach. Now this tube that is posterior to the trachea, posterior to the larynx, posterior to the trachea, this is the esophagus. Now, and if you look here, what it is saying? It is saying upper 5% is voluntary skeletal muscle. This muscular tube, upper 5% is purely 100% skeletal muscle. And if you see distal 50% involuntary, purely smooth muscles, right? So lower 50% is smooth muscle. Upper 50% is divided as upper 5% purely 100% skeletal. But after 5%, this 45% of the upper half, it is a mix. So skeletal muscle and smooth muscles both are mixed in this middle portion. Now, this esophagus pierces the diaphragm at thoracic 10th level to enter into the abdomen. So, can you say this is a stomach? It has to connect. Stomach is in the abdomen, and abdomen is below the diaphragm. This line is indicating a diaphragm. So, in the diaphragm, there is an opening for the esophagus. So, at which thoracic level? 10th thoracic vertebra. So, we always take with the vertebra, right? So, usually take, right? So, T to T10. 10th thoracic vertebral level, there is an opening in the diaphragm through which the esophagus passes into the abdomen. Come to the blood supply of the esophagus, arteries, inferior thyroid artery and left gastric artery. Inferior thyroid artery, you can see here, there is the arch of aorta, and there is the esophagus, right? So this esophagus is a very long tube. So it's not only supplied by one artery, but there are three contributing arteries. The upper part is supplied by the inferior thyroid artery. The middle part are supplied by the branches of the bronchial artery and the aortic esophageal branches. Not the bronchial one, aortic esophageal branches, right? So inferior thyroid artery, the upper part, middle part is usually mainly supplied by the esophageal branches coming from the aorta, right? And the lower part, that is in the abdominal area, right, particularly, they are innervated by the branches of the left gastric artery. Gastric artery, to right and left. So left gastric artery, it gives branches that are called the esophageal branches of the left gastric artery. They supply the inferior 1/3. So upper 1/3, middle 1/3 and lower 1/3. So lower 1/3 is usually supplied by the esophageal branches of the left gastric artery. Now come to the stomach. Stomach, we have got the stomach lies in the epigastrium, lies in the epigastric, umbilical and left hypochondriac region. So in these three regions you will find the in the quadrants of the abdomen you will find the stomach. So it has four main regions: cardiac region means towards the cardiac, towards the heart, surround the superior opening of the stomach. So this is the superior part, this is the esophagus. So this opening, the cardiac orifice of the stomach. So this region that surround this opening is the cardiac region. Then we have got the fundus. Fundus is very tricky. Make a horizontal line from the opening of the stomach, right? The cardiac end. From the cardiac end, make a horizontal line. The area that is above this line, that's a dome shape, right? So that area is called as the fundus and is superior to the cardiac orifice of the stomach. Then we have got the body of the stomach. Body of the stomach. Below this horizontal line, this is a very big body. Till there is a line here. Now, anatomically, we say that this line is actually a vertical line. In the anatomical position of the stomach, draw a vertical line from the point of this angle. This angle is called angularis incisura, right, in Latin, and it is angular incisio. So angular incisio is this bending. Actually, here this is vertical border and this is the horizontal border. So this is an angle between vertical and the horizontal. So this angle is actually called as the angle, angularis incisura, right? And from this angle, if you drop a vertical line, means perfectly it is a vertical line, right? That vertical line will divide the body and the enteron part, right? Pyloric part. So this here in this picture, okay, fine, this is looking more beautiful. So it is a slight curve. So this very big portion is the body of the, so the lower limit of the body is an imaginary line running down from the angular incisura. This is the main portion of the stomach. It extends from the cardiac opening to the angular notch. From the cardiac opening, from here, right, So this whole here below the fundus and up to the uh, angular notch. Angular notch is this. So draw a line from angular notch. This area, this whole area is the body of this. Then we have got the pylorus. Pylorus is what? Beyond this line or anterior to this line that you're drawn from the angular insua, this all area is called pylorus, right? But this pylorus has again two parts, pyloric antrum and pyloric canal. The internal feature of the pyloric canal is that we can find ruggies that are parallel with one another here. But the same ruggies are also present in all the other part of the stomach, but they are not parallel to each other, but they are haphazardly present. So this haphazardness part of the pylorus containing haphazardly placed ruggies, those are called pyloric antrum. And pyloric canal is very parallel. Ruggies are here and they all go to the opening of the pylorus, right? So it is divided into pyloric antrum and pyloric canal. The pyloric canal opens to the duodenum. So this pyloric canal opens with the pylorus, pyloric orifice. Orifice means opening. Now this is the slide for the pyloric sphincter. What is the concept of sphincter? The concept of sphincter is any circular muscle in the long tube that closes the tube. So here there is the esophagus, very long one, and here there is one sphincter called the lower esophageal sphincter. Similarly, there is a upper esophageal sphincters. They are not discussed. Similarly, in the stomach, there is the upper sphincter here, and there is the lower sphincter. And sphincters, they are the circular smooth muscles forming an opening. So when it contracts, it closes the opening, and when it relaxes, it opens the opening. So pyloric opening opens into the duodenum. So this is the duodenal part, start of the small intestine, the first part of the small intestine, and this is the stomach. So between their junction, we have got the sphincter and is surrounded by pyloric sphincter, which is a layer of thickened circular smooth muscles. It controls the rate of emptying of stomach contents into the duodenum. So what is the role of this? When the contents are not broken, this sphincter will close, remains closed, right? When it form a paste of the form of the paste that is called the chyle, so then only this will open and it will allow that paste to go into the small intestine for absorption, because small intestine don't have the mechanical action to break down the foods. The basic purpose is to absorb the food, right? The stomach has two curvatures, the medial border with a lesser curvature and the lateral border, that is convex, called a greater curvature. Now this is the stomach. Can you see the two borders? The one border, this upper border, and this is the lower border, right? From this opening, cardiac opening to all this area, this is a very big one. So this is a very big curve. So that's why it's called greater curve. And there is a smaller curve, that is a lesser curve here, right, on the upper side. So there is a smaller curvature and there is a greater curvature. It has two surfaces, anterior and posterior. So when it is complete full stomach, this is the, we are looking at the anterior side. And here you can see this ruggy. I was talking about these ruggies. They are very haphazardly placed till it become very parallel here in the pyloric antrum, pyloric canal, not the antrum. Antrum is this part where they are not in parallel. Okay. Then we have got this slide, blood supply of the stomach, branches of the celiac trunk. Where is the celiac trunk? So you will find this is the aorta in the abdomen, and celiac trunk is this at the level of T12, and this celiac trunk then gives off branches, the left and right gastric branches. So left and right gastric branches, celiac trunk. This is the trunk divides into three: common hepatic, splenic, and this is the left gastric. So left gastric is visible here. It is going to the left side of the body and then make a turn, and from that turn it runs on the lesser curvature of the stomach, right? So from here, this is the left gastric artery, and the left and right gastric arteries. So left gastric artery and the right gastric artery is this one. So this one, right gastric artery, is a branch of the common hepatic artery. Right and left gastroepiploic artery. So right and left gastroepiploic artery means, now this is the celiac trunk, left gastric artery running on the lesser curvature. Always remember. Then splenic artery. This is a very good splenic artery going towards which structure? Spleen. What is this structure? This is the spleen where the tail of the pancreas touches, right? So there is a splenic artery, but splenic artery, apart from giving the spleen, the blood vessels, it make a big branch. It gives a big branch that is called the left gastroepiploic artery. So left gastroepiploic artery is actually a branch of the splenic artery. And left gastroepiploic artery, it runs on which curvature? Which curvature is this? Greater curvature. So left gastroepiploic artery is a branch of the splenic artery that runs in the greater curvature of the stomach, right? Then we have got short gastric arteries. Short gastric arteries are these. The same splenic artery, it gives blood supply to the spleen. It gives a big branch, left gastroepiploic artery, and then it gives short branches. This short branches that is going to the fundus. So what is the blood supply to the fundus of the stomach? It is supplied by the short branches, right? Short gastric arteries that supply the fundus, right? This is very important. Then we have got the veins. Veins correspond to the arteries drain into the portal vein. So ultimately there is a venous system that ultimately drains to the portal. We'll discuss the portal vein in the end. Then we have got this slide, and this slide got the duodenum, and duodenum has got three parts. And first part, the small intestine actually is divided into three parts: duodenum, jejunum, ileum. The duodenum, that is the first part of the small intestine, it is 25 centimeter long, right? And it is the shortest, widest, widest, and most fixed part of the small intestine. So most fixed part of the duodenum and most fixed part of the small intestine, both. Most of the duodenum is retroperitoneal. Most of the retroperitoneal means behind the peritoneum, means it is not fully enveloped by the peritoneum. So it starts at the pyloric sphincter of the stomach and ends by joining the jejunum. So this is the duodenum, this is the lower part, the pyloric antrum of the stomach, and from the stomach the pyloric sphincter is here. From here onward, this is the first part of the duodenum, there is a second part of the duodenum, third part of the duodenum, fourth part of the duodenum, and this kinking, this is the start of the jejunum, right? So there are four parts of the duodenum, right? Another point, this duodenum is C-shaped tube surrounds the head of the pancreas. So this, in this picture, this is the pancreas, this is the spleen, tail of the pancreas touches the spleen, and the head of the pancreas touches the duodenum. So duodenum has got four parts: first, second, third, fourth. But if you see these four parts of the duodenum, they are according to their uh, location. They can be superior, these are descending, and then this is the transverse or horizontal, and this is ascending. So first part is the superiormost part of the duodenum. Then this one, this is more vertical, so it is called the descending second part, right? Then is a transverse horizontal, and then there is a ascending, the fourth part of the duodenum. Okay, this is the small intestine, again continuation. Now after that duodenum, 25 centimeters, we have got jejunum, that is 2.5 meters, means it is almost 8.2 feet long. And this one is intraperitoneal. So intraperitoneal means inside the peritoneum. Usually the small intestine, duodenum, jejunum. This jejunal part is intraperitoneal completely, right? Many lie in the upper part of the abdominal cavity. Numerous plica circularis and abundant long villi. Now this is very important slide, and this is very tricky and very important and very lovely slide actually. For any anatomist and for any the subject lover, they will love this, because here it is also describing some histology part of the how you differentiate between the duodenum jejunum, and ileum. In the duodenum, we have discussed that it has got four parts and this and that. But in the cut section, what is very important is the presence of the duodenal gland, that is called the Brunner's gland. Brunner's gland, by the name of the scientist Brunner, that is a duodenal gland, is present in the submucosa. Right? How many layers are this? Mucosa, submucosa, muscularis externa, and serosa. Now, this mucosa has got three parts: epithelium, right, the simple columnar epithelium. Then below this white area, this is the lamina propria, and this border, this line is actually the stripe of smooth muscle. That is the smooth muscle of the mucosa. So it is called the muscularis mucosa. So these are the three parts of the mucosa, right? Below the mucosa, in the submucosa, this area, there is a abundant lymphoid gland is there. That is called the Brunner's gland, duodenal glands, right? Now this is for the duodenum. Jejunum don't have the Brunner's gland, right? And jejunum has got this plica circularis as the major numerous plica circularis. So this plica circularis, what is this? This is a submucosa that is elevated. So this submucosa is itself a finger-like projection, and on this finger-like projection there are villi that are also finger-like projection, right? So whenever the plica circularis in the histology is same, this means this is largely present, very prominent in the jejunum, and in the submucosa, and the plica circularis, that is the elevation of the submucosa. In the submucosa, you will not find the Brunner's gland, right? The Brunner's gland, digestive gland, is also not present here in the jejunum. So this is the identification point, that if plica circularis is very much right without the gland, it is jejunum. If plica circularis is broad and there are in the submucosa, you will find a lot of gland. So that is the duodenum. And here the third part is the ileum. Ileum is actually has got very broad, or you can say speed breaker like, right? Plica circularis, very few plica circularis, tall plica circularis, right? And villi, they are also broad. But what is important? Aggregation of lymphoid tissue in the submucosa. In the submucosa, you will not find glandular cells, glands, but you will find aggregation of T and B lymphocytes. And these aggregations, they are called the Pear's patches. Pear were the scientists who discovered these patches in the ileum, and these patches are actually the aggregation of B and T lymphocytes that form the aggregation of the lymphoid nodule, lymphoid follicle, that we have discussed in the lymphatic system. The majority of the chemical digestion and the nutrition absorbed occurs through the jejunum. So jejunum is the main part of the digestive system that absorbs. Now ileum or ileum, it has got 11.5 feet in length, final segment of the small intestine, mainly lies in the lower part of the abdominal cavity. Definitely this is the, here is this the duodenum after stomach, then the blue color, there is the jejunum, and this green color is the lowermost. There are few plica circularis. So here you will hardly find structure like this, elevation of the submucosa forming the very sharp mountainous structure, right? Uh, and stumpy villi. Stumpy means short. The villi, comparing to this one, they are very tall, and here the villi, they are short, right? So short villi without plica circularis with aggregation of lymphocytes is the feature of the ileum. Submucosa contains aggregation of Pear's patches, provide for absorption of nutrients. Okay, ileocecal valve controls the flow of material into the cecum from the ileum. So after this ileum connects with the cecum of the large intestine. Cecum is supposed to be first part of the large intestine. So this ileocecal junction means where they are joining together. That's called the junction. So it is acting like a valve again. Now in the next slide, we have the large intestine attached to the posterior abdominal wall, right? Large intestine is usually again this ascending and descending colon, they are retroperitoneal, right? But this transverse is intraperitoneal, sigmoid, and they are also, sigmoid is also intraperitoneal. Rectum again out. It consists of the cecum, vermiform appendix, colon, and rectum. So what are the major part? This is the last part of the ileum, right? And they form the ileocecal junction on the posterior side. This is the appendix, tail-like. Appendix means something that is extra. So appendices, people like it, this is also called the appendix. Now, this is the first part. The first swelling is called the cecum, right? And then it is the ascending colon, transverse colon, descending colon, and then there is a wave-like bend, right? This wave-like bend, this is the sigma shape. So this is called as the sigmoid colon, and then there is a straight rectum, a very straight one, right? So this is the rectum, and last part 1 to 2 centimeter. This is the anal canal. So it consists of these parts. Then the colon has ascending, transverse, descending, sigmoid. Ascending and transverse part are retroperitoneal, and the transverse colon is intraperitoneal. As we have discussed, this one ascending and descending, they are retroperitoneal. Retroperitoneal means behind the peritoneum. They are not fully covered up, enveloped by the peritoneum, because anything that is covered up fully enveloped by the peritoneum, it is hanging. It is hanging by the mesentery at the back. Special feature of the colon, number one, tinea coli longitudinal muscle are thickened, forming the three bands. Now, there is a story there is a good story regarding uh, this tinea coli and hostrations, right? Tinea coli, saculation. Saculation means sac-like structure, sac. So you can see these are the sac-like structure, right? So this whole large intestine is multiple sac-like structure that is called saculation, right? Anything that is segmented, it is sac-like in sac, saculation, right? And each one sac, that is called as the hostration, right? So this saculation is also called as hostrations, right? Hostration and saculation is the same thing, right? Saculation is derived from the sac. Hostrations, it is derived from hostrum, singular, and this is one single hostra, right? So hostra is singular, that is the one sac. Now, what is the histological origin of these two structures? Tinea coli, can you see? It starts from the appendix, right? And it runs all along the ascending, transverse, descending, and sigmoid. Then after sigmoid, this rectum does not have these tinea coli, these long thread-like structures. Actually, these long thread-like structures, these tinea coli, they are three in number. And what actually are these? In the wall of the digestive system, the gastrointestinal tract, the layer that is the muscularis or the muscularis externa, that contains the inner circular and outer longitudinal. This is the show of these two muscles, because these two muscles after the appendix, they modify themselves, right? What happened? The outer longitudinal layer all along the large intestine up to the sigmoid, right? Not the rectum. What happened? These outer whole covering of the longitudinal muscles, they concentrate in three bands, right? So that those three bands are actually become the outer layer, outer longitudinal muscle layer. So all the longitudinal muscles, they converge, they concentrate in three bands, right? So there are one band that is visible here, so it is actually three. So three bands, they're starting from the appendix, right? Appendix don't have these tinea coli, don't change. But from the appendix arises the longitudinal muscles. They become three bands, tinea coli, and it runs up to the sigmoid. But after the sigmoid, when the rectum starts, there is a straight structure. These longitudinal bands, again, they disperse. They spread, they scatter, and make the outer whole longitudinal muscle layer all around the rectum, right? So this is the story of the tinea coli. Now coming to the hostra or sacule, called sacule or hostra, for saculation and hostration. Actually, when these outer longitudinal muscle layer, they condense into three bands, what is exposed is the inner circular muscle. And these inner circular muscles, they appear as sac-like structure. They become pouches, right? Because they are not supported by the another outer layer, the longitudinal at that side. So what happens? They bag their cells, right, into sac-like structures. So this bagging like structure, this sac-like structure, they form this sac. So these sac, if you say properly, these saculations, they are actually the circular smooth muscle. Here there is no longitudinal outer layer. So inner circular is there in the sacculation, and tinea coli is the outer longitudinal muscles condensed in 3 bands. So sacculation, sac-like pouches, it's wall between the tinea called as, so these hostrations are between the tinea coli, 3 tinea coli, so one anterior to posterior. So here we call it as, so between the tinea bands, these are the hostrations. So single is called hostra, from the hostrum singular. Then the last feature of the large intestine is appendices epipoliaci. Appendices means something extra, something supporting, right? Just like in the books, appendices is written at the end, right? And epipoliaci, it is related to the pertaining to the omentum, right? So this appendix is also covered up by the mesentery. So this structure, when it was discovered, so people call it as an extra structure that is related to the omentum, because it is covered by the double layer of peritoneum. So there is a small pouch of peritoneum filled with the fat. Now next slide is regarding the rectum, and in the rectum we have, as we have said, the word rectum derived from the rectus, means straight. So where is the straight thing? This one. And in the rectum you will not find the tinea coli or the hostrations, because the tinea coli now is scattered and they support the inner circular layer. So there is no pouching, there is no sac-like structure of the circular muscle, and only the longitudinal muscles and outer longitudinal muscle is visible here. Now, rectum begins at the continuation of the sigmoid colon and forms and lasts for 15 centimeters of the digestive system. 15 centimeters is hardly more than 1 feet, right? But this is very, very important. Why? Because it ends in front of the tip of the coccyx by piercing the pelvic diaphragm and becoming continuous with the anal canal. Now, the next part to the rectum is the anal canal, right? But here it is showing the exact location of the rectum, where it is located. It pierces the pelvic. It is in front of the tip of the coccyx. Coccyx, we can palpate the last point, the last vertebra of the vertebral column, right? So it is in front of that, right, inside the pelvis, and it pierces the pelvic diaphragm. Where is the pelvic diaphragm? This is the muscle. Just like the diaphragm between the thorax and the abdomen, there is a diaphragm between the abdomen and the perineum. Not the pelvis, but the perineum. Perineum is the lower part below the area that is below the uh, urogenital diaphragm. So this is the muscle, and this muscle is composed just like or rather just opposite to the diaphragm between thorax and abdomen. It is a singular muscle, right? It's composed of one muscle with the dome tendons in the center and the peripheral muscles. But this levator ani, this urogenital diaphragm, that is composed of levator, several types of levator ani, right? So here this muscle, this is the levator ani, this is one of the major contributor of the urogenital diaphragm. Urogenital diaphragm. So this is called as the urogenital diaphragm, the diaphragm between the genitals and the urinary system. So we will study later. So in front of the tip of the coccyx, we are piercing the pelvic diaphragm. So this urogenital diaphragm is called as the pelvic diaphragm. So pelvic diaphragm and become continuous with the anus. So this rectum, that is a straight structure, it pierces this diaphragm, just like the aorta and the esophagus and the inferior vena cava. They were piercing the diaphragm between the thorax and the abdomen. Same here, this rectum, its last part also pierces the pelvic diaphragm. This composed of levator and eye muscles, different. So, and then after piercing, it goes to the perineal region, and in the perineal region, it becomes continuous as the anal canal, right? So anal canal is the last part. So above the pelvic diaphragm, the structure is very straight, rectum, and below the pelvic diaphragm it is anal canal. Now it is also that rectum is expandable for temporary feces storage. Sometimes when you go to the toilet and go to the defecation, you'll find sometimes a very continuous structures come out down, right? So that is actually stored primarily in the rectum, right, and continuous with the descending colon. So actually this rectum is designed to uh, capacitate to store the extra fecal material, right? That's why sometimes in 2 days, 3 days, when it is very is constipation, you are not going to the toilet, so it accumulate, it become a very thick, and it very hard to, very difficult to evacuate or get it out of the body. So muscular coat rectum is arranged in usual outer longitudinal and inner circular layer. As I told you, the rectum does not have the tinea coli, because all the tinea coli that were condensed previously till sigmoid, they are now spread out, and they form a, now in the rectum they form a layer, outer longitudinal muscle layer. Now after the rectum is continuous with a 4 centimeter long anal canal. So rectum is finishing here, right? And this is the anal canal, right? This is almost 4 centimeter long and passes down and backward from the rectum ampulla to the anus. Ampulla is the distended part of the last distended part of the rectum is the ampulla of the rectum. Except during defecation, its lateral wall are kept in apposition. Anal canal, it is talking about the anal canal. Definitely anal canal, just like the stomach, it has got two sphincters, and the cardiac and lower esophageal sphincter and the pyloric sphincter. Then there is a sphincter between the ileum and the large intestine, the cecum, ileocecal junction, right? Then this large intestine, when it is opening at the anus, again there is a sphincter, and there are two sphincters, two layered sphincters. One is the inner, the other one is outer. The inner one is voluntarily controlled, it is not under your control, but the outer one is voluntarily controlled because it is skeletal, it is innervated by the spinal nerve. So so that's why you can control your defecation, you cannot defecate in the class. Now next slide is related with the blood supply of the digestive system. That is again a very important slide, because the blood supply embryologically, if you see this picture, you can see this is the esophagus, this is a developing stomach, and then stomach, there is the pancreas, there is the spleen, and after the duodenum, stomach, there is the duodenum, ileum, jejunum, right? Duodenum, jejunum, ileum, and again this is the ileum part. And after that, can you see this bulge, small bulge? This is the cecum. Cecum is the point that it means that this is the start of the large intestine. So before that, this is all a small intestine, and after that, this is a large intestine, right? Now coming to the point. Now, can you see this artery? This is the aorta, and this is the picture of the when the fetal is developing in the mother womb, right? Uterus. Now this aorta gives three main branches: 1, 2, 3. The upper one is called a celiac artery, the middle one is called superior mesenteric artery, and the lower one is called inferior mesenteric artery. If you understand the embryological distribution of the blood vessels, then you can understand the gross anatomical distribution of the arteries. Now here we can say celiac artery, this is reserved for the foregut. Superior mesenteric artery is reserved for midgut. Inferior mesenteric artery is reserved for hindgut. Now we know gut, gastrointestinal tract, is a tube-like whole structure from oropharynx esophagus to the anus, a tube-like structure. Now from where to where it is called forebrain, from where to where it is called midbrain, and from where to where it is called hindbrain. Just like in the brain, forebrain, midbrain, hindbrain, here is also a demarcation. The forebrain starts from the lower part of the esophagus, right? And it ends where the main pancreatic duct, it penetrates the second part of the duodenum. This is the exact point where it is the demarcation, is that before this penetrance, this opening of the pancreatic duct, common bile duct, into the second part of the duodenum, above that, that is all the forebrain, and below that point is the start of the midbrain. Oh, sorry, above is the foregut and lower is the midgut. And this midgut here in the picture, if you could trace it, esophagus, duodenum, and duodenum is here. So somewhere here there is the pancreas, and pancreas is opening somewhere here in the pancreatic common bile duct, right? Now up till here, this is all foregut, right? Means before, and from here the penetrance of the pancreatic common bile duct into the second part of the duodenum. From that onward, the midgut. So you can trace this midgut here. This is very important to understand for the whole life, right? This is the midgut. Midgut starts from the lower part, from the penetrance of the common bile duct in the duodenum, second part, right? So third part, fourth part is the part of the duodenum that is in the midgut, and the first part and the second part till that point of penetrance, this is in the foregut, right? So from this third part and fourth part of the duodenum, then the jejunum whole, and then the whole ileum, and then can you see this this artery, this artery that is supplying this area, this is the superior mesenteric artery. So the purpose of describing this foregut, midgut and hindgut is that there are three arteries supplying the foregut, midgut and hindgut. The foregut is supplied all by the celiac artery, midgut is supplied by the superior mesenteric artery, and the hindgut is supplied by the inferior mesenteric artery. Now, if you trace this superior mesenteric artery, it is branching in this third and fourth part of the duodenum, right? And then jejunum, whole of the jejunum, then the whole of the ileum, right? And this branch also giving the start of the large intestine, the cecum, the appendix, the ascending colon, and then it ends up here in the transverse colon. So in the transverse colon, it supplies only the proximal 2/3 of the transverse colon. And then the distal 1/3 of the transverse colon, and later on the sigmoid colon and all the descending colon, sigmoid colon, rectum, they're all supplied by the inferior mesenteric artery. So come this story with a slide. Foregut from esophagus to second part of the duodenum. Why second part? The point where the common bile duct and the main pancreatic duct, they penetrate in the major duodenal papilla inside the second part of the duodenum. So this include also the liver. The foregut also include the liver, accessory structures, pancreas, spleen, and they are all supplied by the celiac artery or celiac trunk, right? Celiac trunk, wherever the trunk, just like pulmonary trunk, it divides into branches. Celiac trunk, it will divide into 3 branches. Celiac trunk is a very short, arises from the abdominal aorta at the level of the 12th thoracic vertebra. This is important. It has 3 terminal branches. Yes, because this celiac trunk arising at the T12 level, it divides into 3 branches. Now here, this is the celiac trunk arising, very short one. But as it arises, it divides into 3 branches. One going to the right, the other one goes to the left, the other one going also to the left. Now, first, this branch is called left gastric artery. This one is called splenic artery, and this one is called common hepatic artery. So these are the 3 main branches of the celiac trunk supplying the lower part of the esophagus, whole of the stomach, the duodenum, upper 2, and the spleen and the liver, or it supply all part of the foregut, right? So you should know which structures are included in the foregut. So in the foregut, we have got lower part of the esophagus, stomach, first 2 part of the duodenum, then accessory glands, pancreas and the spleen, the liver, they're all supplied by the celiac artery. Now this is the next slide related with the blood supply of the digestive system. So here we can see that there is the midgut, and you can see the midgut is mainly supplied by the superior mesenteric artery, and this is the superior mesenteric artery, and the first branch of the superior mesenteric artery is the inferior pancreatico-duodenal artery that supplies the pancreas, the head of the pancreas, and the duodenum. As later on it moves ahead, it gives branches to the jejunum, and then you can see this is the ileum, this is the ileum part, right? And then it also gives a branch to the appendix, appendicular artery, then the cecum, ascending colon, and then it will go and stop at the transverse colon. But that transverse colon is divided into 3 1/3 So the proximal two-third of the transverse colon, it is supplied by the branches of the superior mesenteric artery and not by any other, right? So this is the last point where the superior mesenteric artery supplies the blood. So this superior mesenteric artery ends up here. So second part of the duodenum. Now the start of the superior mesentery, it is starting from below the point where the common bile duct and the pancreatic duct, they penetrate the wall of the second part of the duodenum at the major duodenal papilla from inside, right? So this major duodenal papilla is actually the division, the cut point between the foregut and the midgut. So this midgut is supplied by the superior mesenteric artery. So the lower half of the second part of the duodenum and the third part of the duodenum and the fourth part of the duodenum, they are also innervated by the superior mesenteric artery, right? So here that's why it is showing some part of the duodenum here. So third part, fourth part, and the jejunum and ileum. So these are all the structures that will be innervated by the uh, superior mesenteric artery. Now this is again next the blood supply to the large intestine. The third part of the large intestine that relates with the third blood supply, the inferior mesenteric artery. The inferior mesenteric artery, it lasts from the distal or the last one-third part of the transverse colon to the upper part of the anal canal, right? So if you see here, there is the inferior mesenteric artery and it starts giving branch to the distal one-third of the transverse colon because it is cut down. So the transverse colon, this is the distal one-third, right? The two-third remaining that was supplied by the superior mesenteric artery. The distal one-third of the transverse colon, and then the descending colon, and then the sigmoid colon, then the rectum, right? Till the upper part of the anal canal. They are all blood supplied by the inferior mesenteric artery. Then we have got the inferior mesenteric artery. About the third point is related with the origin of the inferior mesenteric artery. So here this origin of the inferior mesenteric artery is just above the bifurcation of the abdominal aorta. So abdominal aorta usually bifurcates at L4 or L4, right? And 3.8 centimeter above its bifurcation point, this artery arises. So inferior mesenteric artery is 3.8 centimeter above the bifurcation point of the abdominal aorta. So it terminates at the superior rectal artery. So what is the last branch of the inferior mesenteric artery? This is the inferior last branch. So this last branch is going where? To the anus, right? So anus has got several three. So the superior artery, superior branch is coming from the as the last branch of the inferior mesenteric artery. The inferior mesenteric artery supplies the distal third of the transverse colon, left colic flexure. Colic flexure, what is this? Flexure means derived from the flexion. Flexion means bending, right? When the degree between the two structures, it is decreasing, right? So can you see here, this is one transverse colon and descending colon. Here the bending is there. So this bending is called flexures, right? Since it is in the colon, so it is called colic flexures. Colic means related to the bending of the colon, colic flexure, and sometimes it is called as the splenic flexure in the colon, and there is hepatic flexure on the right side. Then the descending colon, sigmoid colon, rectum, and the upper half of the anal canal. So this artery, it goes down to the anal canal also. It completely supplies the rectum and even the anal canal, that is the next part. On the upper area of the anal canal is also supplied by the last branch of the inferior mesenteric artery and the superior anal artery, superior rectal artery. So superior rectal artery is here, right? The lower part of the rectum and the anal canal is supplied by the middle and inferior rectal arteries. Superior rectal artery, middle rectal artery, and inferior rectal artery. Superior rectal artery is actually the last branch of the inferior mesenteric artery. Middle rectal artery, inferior rectal artery, these are the systemic branches from the hopefully pudendal arteries, right? So pudendal artery is one of the branch of the internal iliac artery. So internal iliac artery give one of the branch, pudendal artery. Pudendal artery give branches to the middle and inferior part of the rectum called as the middle and inferior rectal artery. But the rectum also got the superior rectal artery, but that superior rectal artery is actually a branch coming from the inferior mesenteric artery, right? Now this is the a slide regarding the portal venous drainage. First of all, you should know that venous drainage from all the parts of the digestive system, it ultimately go to the liver and through the vein that is called the portal vein, right? So this is the portal vein from here to here. This is the portal vein and it is going to the liver. So starting from here. Now the question arises, which two tributaries unite together to form the portal vein? So this is the portal vein starting from here going into the liver, and in the liver it divides into right and left portal branches, right? Right hepatic vein, left hepatic vein. This portal vein is formed by the combination of this vein and this vein. This vein is called as the splenic vein. It is coming from the spleen, right? Also take from the pancreas. But the name of this one is very long one, is splenic vein, right? This inferior mesenteric vein also drain into the splenic vein, right? So this splenic vein also drain the pancreas, and the inferior mesenteric vein also drain into the splenic vein, and this vein is superior mesenteric vein. So superior mesenteric vein and splenic vein, these two combine to form the portal vein, and portal vein ultimately drain into the liver, and from the liver these vein when they combine together to form the hepatic vein, and hepatic vein then ultimately drain into the inferior vena cava. Now, the venous blood from the greater part of the digestive system and the accessory organs drain to the liver by the portal venous system. Now, what is portal vein? Drains blood from most of the GIT from lower third of the esophagus to the halfway down to the anal canal. So, from where to where? Actually, it is draining from the midgut, hindgut, midgut, and foregut. So that's why it is saying it's a very large distribution. So from the lower third of the esophagus up to the anal canal. It also drains the spleen, pancreas, and the gallbladder. The portal vein enters the liver and breaks up into sinusoids. So what this portal vein come here and divide into right and left hepatic veins, and these veins when they go into their respective lobes of the liver, they form sinusoids, means dilated capillaries, right? And where these blue deoxygenated blood, they are coming here. So these are the hepatic sinusoids, right? They converge to form the hepatic vein that ultimately drain into the inferior vena cava. The portal vein enters the liver, breaks up into sinusoids from which the blood passes into the hepatic vein that join the inferior vena cava, right? So hepatic vein join the inferior vena cava. Tributaries of the portal vein. Tributaries of the portal vein are the splenic vein, superior mesenteric vein, left gastric vein, right gastric vein, cystic vein. So portal vein from here to here. Now here it is giving the tributaries, means the branches. In arteries we say branches, but for venous system we say those branches as tributaries. So this is the tributary, right? The gastric. So superior mesenteric vein, left gastric vein. This is the left gastric vein, right? Then we have got the right gastric vein. The right gastric vein. We have got the right gastric vein, left gastric vein. These two. Then we have got the cystic vein. Cystic vein is here. This is the gallbladder, the neck of the gallbladder, and there is the cystic duct. So there is the cystic vein. So these are the tributaries. Upper third, 2/3 of the esophagus drain into the azygous vein, systemic circulation. Now above this one, for the esophagus, the we divide the esophagus into upper, middle, and lower one third. The lower one third arterial supply was the esophageal branches from the left gastric artery, and the venous drainage of the lower one third is through the esophageal veins that are the tributaries of the left gastric vein, right? But these veins, they will go and the part of the portal veins, right? So portal veins, they are indirect veins. They are not going to the heart. They are supplying to the liver, right? And for the esophagus middle part and the upper part of the esophagus, they are supplied by the azygous vein, the venous drainage of the middle part and the upper part of the esophagus. It is through the azygous vein, and azygous vein is a part of the systemic circulation. It is not the part of the portal circulation. Portal circulation related to the portal vein, right? So here there is a junction in the esophagus between the part upper two-third and the lower one-third. Lower one-third, the venous drainage is going to the portal system, and the upper two-third of the esophagus, it is actually the venous blood is going to the systemic circulation through the azygous vein, right? So here there is a junction, that anastomosis. So that anastomosis is called the portosystemic anastomosis. So lower half of the anal canal, the same anastomosis between portal and systemic venous blood is also there in the anal canal, that is drained by the middle and inferior rectal veins. Now, middle and inferior rectal vein, I told you, just like the artery, these are the tributaries of the portal of the uh, pudendal vein, right? So pudendal vein is a branch from the internal iliac vein, right? So these veins, these are the systemic veins going there to the heart, right? But the rectum, the superior rectal vein is this one. This is a tributary of the inferior mesenteric, just like in the artery, superior rectal artery, the last branch of the inferior mesenteric artery. So the last branch of the inferior mesenteric vein is the superior rectal vein. So this superior rectal vein is draining the deoxygenated blood from the rectum into the portal vein. And so this rectum has also got an anastomosis, portosystemic anastomosis, between the upper one part, the first upper one third, and the lower two third of the rectum that was supplied by the middle rectal vein and the inferior rectal vein. Those were the branches of the pudendal vein, the systemic vein, right? So systemic portal anastomosis is also present in the rectum. Thank you very much. Alhamdulillah.